which all of you are. I'm speaking to the ones who are not here. So, if they are in. Okay, so welcome. Today we're going to be learning about bioinformatics. Hopefully you are here to understand what bioinformatics is, and please come in. And this is the Intro to Bioinformatics course. It's the semester 1, the long course that will go on from now for a very, very long time, or so it might seem. So we'll have 14 lectures and 12 practical sessions over the next 13 weeks. So as you can see, there are more lectures than practical. So some weeks there might be that there is a lecture on 2 days, and so like Tuesday there's 2 hours of lecture, and then Wednesday there might be a 1 hour of practical. This will all be done with coordination with you, but those are only 1 or 2 times. And those are the lectures that are extras. They're not the ones that are part of the series. Like for example, I give a lecture on machine learning. So that's the extra additional lecture. For example, that's towards the end. The lecture on pipelining and making pipelines, that's an additional lecture. So I don't know if you attended the info session, but these are some of the extras I offer as part of this course. Is, apart from learning the RNA-seq pipeline and the ChIP-seq, we also learn extra stuff like mutation invariant calling, how to make pipelines with the software using your knowledge, and then also how to understand basic machine learning concepts, so that when you're sitting in a talk which has machine learning in it, you don't feel completely lost. You'll still be lost, but not as much. Okay. The last class is second week of December. I say tentatively because it can be before that. It's not going to go after the second week of December. All right. So by December 15th, we should be done with this course. We will be done with this course. Before that is possible, but not after. So today we have 1 lecture and 1 practical. So I'm still speaking with Dr. Cheng, who gives a lecture on sequencing technologies. It's possible it's next Wednesday. Otherwise, it's also possible that he might make this take a Wednesday in October, like October 2nd. That's the one that he's saying. But there will be a lecture from Dr. Cheng. Okay. Is this recording? It is recording. Okay. All right. Apart from that, grades. So you may receive grades if you would like. Sorry. No, it's okay. Yeah, it's no problem. Grab a seat. There's a chair over there if you'd like. So, right. So far I have had 2 people who have taken this course for a grade, and I have had so far more than about 110 students that have gone through this course, and only 2 have taken it for a grade. If you happen to be the 3rd one, I would say that that's possible. You can receive a letter grade for the end of the course with an informal certificate of completion. Informal because we're still not part of the Harvard Medical School. We're not an accredited course yet through HMS. The process is ongoing. It's been going for the last 2 years. I've been trying to get it done, but it's a long bureaucratic nightmare. So till then, you can get a letter grade. If you want a grade, here's a breakdown. I'll give you 6 homework assignments. That'll be 25% of your grade. There'll be a final exam for you. That'll be 30% of your grade. And then there's a data analysis for an RNA-seq ChIP-seq experimental project that you have to come up with, and I'll help you with that. That's 40% of your grade, and you have to give a demo at the end of the course. This is only if you want to get a letter grade, like a A or a B or a C. Yes?
What does it mean, demo?
A demo, basically, you will be presenting your data and the analysis like you would do at a lab meeting. Presentation. And you may form a team of 2 people if you find another person who is also interested in taking a grade. Any questions so far?
If we are not interested in taking the grade, we have to go through the homework assignments. But
okay, so you don't have to. It is highly recommended. Just like with any course, if you don't follow the material, the best way to learn a material is to work through it in computer science. So again, we are grown-ups here. I can't say you have to, but I would highly recommend.
And should we tell you now if we want a grade or no?
You can tell me tomorrow or by the next week. All right, so something about math. Nobody asked, so this has to be taken out because nobody asked. Because their 5% of your grade is missing in the following math? I don't know if people really read this.
The 25.
See? Like so, this was a trivia puzzle which nobody got right, so you missed out on a bonus point here. Alright, so 5% of it grade is for the following. I highly recommend this, that after every class, I'd like you to email me one or more things that you did not understand in the class today. This is very helpful for, not just for you, but also for all the other students who might want to ask something but didn't have an opportunity. I also, sometimes I'll put these things on the website for this course, where then, under frequently asked questions, you can look up the answers to what problems you've had or students from the past have had. So you email them to me at my email, which is this, by the end of the class. That way we all stay current. Okay, so just in case you need it, supposing you're traveling, there's a conference, or life just gets busy, the video for each lecture will be made available for at least the duration of the course and afterwards as well, but and it's made available usually by, I would say, Thursday night or Friday, because it takes me a day to go back and upload, edit the video, in case I say something that's censored. most of it is good stuff, but I'm saying by the end of the Thursday night, I'll put up this video that I'm taking now. It's being recorded, and the lecture and the presentation is also posted at this site, intro-to-bioinformatics.com. Now, most of you should have gotten an email from me with your user ID and password that allows you access to this website. If you have not, send me an email, and I will make sure that you get access to this website. This is where I post the videos, this is where the presentation is, where the course material is. So if you're registered for the course, you should have access to this website, all right? And you have lifetime access to this. So as long as I can, I will be keeping this server alive. So you will have access to all the materials that are done in this course, including videos, presentations, exercises. And we take, and in the meantime, say you want to look at the information, a video. So usually what I do is I keep the video for last semester. So let's say tonight you want to go watch something. So this video is from last semester, is already here online. Alright, so if you don't want to wait till Thursday night when I post the video, you have the video from last semester, which is mostly similar, because the course hasn't changed that much since last semester. Okay, so Wednesdays are optional. And some Wednesdays in October, actually Wednesdays in October, we won't be having this class because we're going to run another course on single-cell RNA-seq 2 to 4 on Wednesdays in October. So these Wednesdays in October are optional, but as even otherwise, the Wednesdays, you don't need to come in unless you've missed class. Say you missed class today, I would recommend that you come tomorrow, so that way we can sit down and go over what you missed, all right? This is also my office hours, so if you have any doubts, if you're working on a project, you need some help, that's the time to come in, all right? That's the time for consulting, that's the time for one-on-one questions. And Wednesdays, while it's 2 to 3, I'm happy to stay longer if you have more questions. Does that make sense? All right? But please be here by 2. So just because it's 2 to 3 doesn't mean you show up at 3. Do you know what I mean? Because I need to plan accordingly, and we go over some things. So if you're here at 2, then we can cover whatever you have on Wednesday. Okay, as I said, Wednesdays in October will not be meeting just because we have that. So in lieu of those, you can email me and I'll arrange a time for you in October personally. In fact, that's even better because you get one-on-one time instead of having a group time in October. Does that make sense? So because Wednesdays in October are booked, if you email me at that time that you need some help, I will sit down with you and go over whatever you need help with. Okay? Okay. Finally, and also you can also do that not in any other month as well. Like you can just email me and I'm very approachable. I'll sit down with you anyways, right? Not just because it's in lieu of this. So all work on the server shall be put in this directory. So there's a directory called PHS Home on the IRIS-1 server. Don't worry, you'll find it when you log in. Don't worry about what a server is. We'll go over that in a bit. But whatever is your username, when you log into the server, you log into this default directory. This is your default directory. That's where you'll put all your work. You're not going to put it anywhere else on the server. So whatever is your username, and that's the directory on the server in which you will have your, just so that it stays contained in one directory and doesn't, you don't do anything to something else. All right? But you'll understand more about this once we get into the server, and also you'll understand what a server is once we talk about it in a minute. Okay? Okay. So I do ask that you promise to work hard on this course. That means participating in class discussions, doing the reading required at home. So there's not much reading. Don't worry, it's not a lot. But sometimes I'll say like, hey, take a look at this paper, or take a look at this set of commands. Just small. It'll probably take you less than an hour. But I expect that you do that. And approaching me after class if you don't understand the material and did not want to ask me in class. This part is the most crucial part. A lot of times I found that no matter who we are, our nature tends to be that we just are not that extrovert at times. Like maybe it's a science thing. People who come here just tend to be more internally motivated. Either way, I would highly recommend that step out of your comfort zone and ask me outside of the class or during class if you have any issues. The worst thing that can happen is that you miss a class or you miss 2 classes, and now you're completely lost and you lose all motivation, because that's a spiral, right? It works like that. You just lose all motivation by the time you miss. You're in the 3rd class that you're not understanding. That's over. For you, the course is over. So as soon as you don't get it, approach me. And then try to attend all lectures and practical sessions in person. Even though the option is there for the video, please make sure you attend in person. Because the learning that happens in person, the interaction, you'll miss out all the jokes. They don't sound so funny on the tape. All right, and then give this course priority. All right, so I know we all are busy. We have our different work. So this is also important. Like sometimes we will think of this as like, oh, it's just something else to do. If you give it priority, trust me, it'll really help you in the long run. All right, in the long run, you'll come out a lot better. Okay, so with that, let's start with Unix commands, which is our first lecture for today. Before we go into the actual lecture, let's talk a little bit about today's goals. So what do we want to achieve today in this next 1 hour? So let's focus on the big picture, and let's not get caught up on learning each command in Unix. So first we'll go over what Unix is. We'll cover what are commands. But the one thing you want to get today is there are lots of these so-called commands in whatever this Unix is. We'll talk about that. But you don't want to focus on how many learning each command. You want to focus on the big picture as to understanding what a command is, or what is Unix, what is the purpose of having these commands. Because you can always Google something and find that answer, but you want to understand what is the big picture. You want to understand what servers and clients are, and how you can use them for your work. This actually goes for everything in this class. Anytime you're learning something here, just try to put it in context and how does it relate to my analysis for my project, right? If you don't have a project, think of your future project that you will have. And think about it like, oh, can I use this in my project in some way, right? That'll make you more motivated. So if you're falling asleep, you'll suddenly wake up if you start thinking about your project. Okay. And then, lastly, let's take small bites of Unix. Those of you who don't get it, it's fine. All right. Let's get started. So what is a server? Does anybody here understand the terminology, or a client, or a network, or a cluster? Any of this?
I know cluster.
Yes, okay, what is a cluster? Let's start there. Let's start here. What is a cluster?
So a cluster is when you have like as a Disney figure, for example, a Disney plot. When you have like a certain potato of cell population, that's
Yes.
what you call in research or biology.
Yeah, that's a cluster.
Exactly, so we call
Correct.
it a cluster. So sometimes for
Why is it
example,
called a cluster? Because it's a group.
because they do share similar gene expression, and that's
Perfect.
why the cells or the dots, they do cluster together.
Right. So in that sense, a cluster is a grouping or a bunch of things, right? In this case, in your example, it's a group of cells.
Yeah, I speak biology.
Perfect, perfect. So that's very interesting perspective, because as a computer scientist, I do not think of cluster like that at all. The first thing that comes to mind is not that. So that's why I'm saying, like, we look very similar, but when we talk, a cluster in biology is completely different from a cluster in computer science. All right, let's talk about a little bit more. So anybody else want to take a gander at what I'm thinking when I say cluster? Yes.
Like a grouping of computers, I guess, all
Perfect.
together. Yeah.
That's correct. So you are thinking cells, which is great. I'm thinking computers. So a group of computers is called a cluster. All right. So in a cluster is basically a group of computers which are there for a specific purpose, and that specific purpose is to work on and analyze data. Right. Most likely. Right. That's a cluster in this sense. Okay. So we jumped a little ahead. Let's go and come back a little bit and try to understand what a server is first. All right. So basically a server is any computer whose job is to receive requests. All right. And those requests are usually to do a certain kind of analysis, or to provide some sort of feedback, or to give some sort of data back. But a server is a machine like a computer. So this machine here could be a server. Right? So what is the difference between this machine and the IBM Watson server? Have you heard of the IBM Watson server? Okay, so IBM Watson server is this huge computer which was basically, I think a few years ago, became really famous. It defeated the contestants in Jeopardy. So it was trained using artificial intelligence to work as as a separate entity, so it could answer questions. It didn't know these questions, but it had so much data and it was able to crunch all these possibilities and come up with answers, and then it defeated a human being. So that
there's no difference.
there is no difference, except that IBM Watson server has a lot of these similar computers with combined together, and it works as a cluster. All right, so it was working as a cluster, whereas this is just one standalone machine. Even though this itself could be a small server. So any machine can act as a server. Any computer can act as a server. Right? What a server does is it takes a request and then provides a result. For example, when you type in your web browser, you type www.google.com. That, and you press enter. That introduces a request from your browser that goes to the server for Google. And then Google says, oh, somebody from this IP, this location, your browser, wants to the Google homepage, which is the Google, the thing that pops up. So it sends that data back over the internet and displays it on your browser. And that process, that interaction happened because Google has its server ready to take requests from you. So that is one kind of server. It's called a web server. So the Google server is a web server because it works on the internet, provides you web data back and forth. All right. In this example, what I just gave you, your computer acted as a client. All right. A client is a computer that, in that particular interaction, is sending the request to get something from the server. All right. Most likely, that thing is data of some form. Okay. So now we have understood client and server. A network is a collection of clients and servers. So in a network, you will have a collection of clients and servers which are linked through either direct link, which is cables. So you can connect it used to be that every computer would be connected to the network. It still has, you still have those LAN ports over there behind you, those ports. You connect them with a wire. And that data now can go from your computer through that wire to a local hub or a router. And then the router is connected to a routing server, and that server sends your request to other servers and stuff like that. So that's a network. Is that clear? Are you guys with me so far? Okay. So that's a network. So then a network is a bunch of servers and clients. A cluster, I told you, is also a bunch of computers combined together, working to do some data analysis. So what is the difference between a network and a cluster?
So the cluster is a bunch of computers combined together to do analysis.
Yes.
And what is the difference between cluster and network?
That was my question. Yes. Are you asking me my question?
No, I'm repeating it to make sure I got it.
Because that would be very smart. It's like so. Okay, so the difference between a network and a cluster is that in a network, most of the times it could be a network where computers are connected for exchange of, say, web data, and it also includes routers and other things. Whereas in a cluster, your cluster is a kind of network where the computers are connected only solely for the purpose of data analysis. Does that make sense? So network can be a network of computer that is connected to create an intranet. For example, you heard of Napster? And there was this company called Napster, which was a peer-to-peer file sharing system. It's pretty old now, but it used to be that you could connect computers. You could connect to the site and download music illegally, which you don't need to anymore because you have Spotify. But back in the day, there was this thing called Napster, where lots of people would collectively share their music with each other, and that kind of network, that would be a network, because you're basically all connected through a router or an internet, but you're not really doing any, you're just exchanging data. You're not doing any calculations. Clusters are specifically designed for high-end calculations and data storage. Okay, so that brings us to the last one. What is the MGH cluster called? Anybody? What if I told you in the last 24 hours you have heard of this name? The MGH cluster's name? Eris, yes, that's the cluster's name. ERIS-1. ERIS-1. Enterprise Research Information Systems 1. That's the ERIS-1 is the cluster for MGH, and hopefully when you submitted an application, if you have already and your application was approved, now you have an account on that cluster. All right? What that means is that you are now ready to do high-end calculations and crunch lots of data on that cluster, because that's a really big cluster and it's very powerful, and we can do lots and lots of calculations over there. Right? So you guys are there, you're ready. Now all you need to know is take 3 months of bioinformatics and then you'll be fine. You'll be able to run jobs on the cluster. Okay, so now that we understand what a cluster is, what a server is, an important thing comes up, which is what is Unix and why do we need it? Hey.
Sorry.
Sometimes this doesn't. Yeah. So what is Unix? Well, so Unix is an operating system. Do people understand what operating systems are? So operating system is the software that helps a computer hardware do things, and the user helps the user interact with the computer hardware. So that's the operating system. For example, when you work on your laptop right now, some of you are having a Mac, some of you are having a Windows. But the difference is that you could technically install a Windows operating system on your Mac machine. It's possible, it's doable. And sometimes people install other operating systems on MacBook, for example, as well. So the operating system right now is your OS X. They call it OS X, whatever version you are on. There used to be Sierra and then Mountain Lion and all those other things. Those are all versions of operating system. So just like you have an operating system in your laptop, you have an operating system on the server. The operating system on the server is in Unix or some form of Unix. Does that make sense? Right? So in order to interact, just like in order to interact with your computer, you will be, using your mouse and clicking and opening Finder, launching applications, doing all this stuff. You open applications, you open, your mail application, something else. Similarly, on the server, to open and run applications, you have to use this operating system, and through it, you are able to launch applications, run programs, do all the other things that you can do. Does that make sense? Okay. Now, this operating system, Unix, is one of the oldest operating systems. It's mostly written in this really wonderful language called C. It's very old, very powerful. The important thing about Unix is that it offers you machine independence. So if today you install this operating system on this machine and tomorrow you take another machine and install it on that, it will behave exactly the same. There won't be any difference in the operating system's behavior based on the machine. So that was a radical concept when this operating system was written, and it provides a number of facilities. It helps you manage the hardware. So do people understand the difference between hardware and software? Somewhat? Do you want me to go over it? Yeah, okay, so hardware is basically when you open up your MacBook. Has anybody opened a MacBook? Okay, one. So if you ever open up your computer or even a simple thing, you will see that there are different components inside. You have a hard drive, is a separate thing. You have I mean, they don't have it anymore, but they used to be DVD drives or CD drives, and you can find the speakers, the actual speakers that make the sound when you play music. And this display is also, you can change the display. You can take out the display and you can replace the display, right? So when you take it to the MacBook, those geniuses over there, they replace the stuff for you. They're like, oh, you need more RAM. So RAM is actually a chip. You can open this up and put a new chip in it on your own. You can do it if you want. So anyways, so all of those constitute the hardware. It's physically present. You can touch it. You can feel it. The software is the thing that actually works. The operating system is software. Software is just a bunch of code that manages this hardware. It helps the user interact with this hardware. Does that make sense? Okay. Now, the Unix software or the operating system, Unix operating system, helps you manage hardware. It helps you interact with the directory and file system, just like your Finder. It helps you find what are the directories, what are the files. It helps loading and executing and suspending programs. Again, think of it in the context of your operating system, exactly the same thing, right? That Unix does. So, why use Unix? Well, first of all, when you bought a MacBook, you had to pay for the operating system and the hardware. All right? Unix is free. I can take a $50 junk computer, install Linux on it, and it becomes, I can make it into a server and launch my own website for free. And I did that in grad school, by the way. It's entirely doable. I found this similar machine like that just lying around in a department. They didn't need it, they'd thrown it out. I was like, can I have it? I took it, reinstalled, wiped out the hard drive, installed Linux on it. Within 2 days, installed a web server software called Apache. Within 2 days, I had a functioning website on it. So it was a website server for free. There's nothing you can do. So it's all free. And that's the best thing about Unix, that it's free. It's multitasking, multi-users. Multiple users can connect into a Unix operating system without knowing that other users are connected. So say all of us connect to the server at the same time, even if the server is just that machine with a software, all of you will feel that you are the only ones on that server. You will never feel that there's anybody else, right? Yes?
I feel like this is a really dumb question, but I've always wondered what is the difference between Unix and Linux?
Perfect. So I was going to come to it, but great question. Unix is think of it as the first version that came out. And then people started writing multiple different features, adding features to Unix. And then the core was the same. They maintained the same core, and they added more stuff to it. And one of those versions became Linux, other one became FreeBSD, the third one became GNU. All of those are just versions. Did you know that you actually, if you, for example, right now, have a version of Unix running on your computer? So every MacBook comes with Unix installed on it. Because Mac's software is basically built as a paid version of Unix. All of this software is a paid version of Unix that you're using. So they took the free thing, they took the free Unix, built a bunch of GUI, not GUI, I shouldn't say. Well, GUI is actually graphics. Wrote a bunch of code on it, made this pretty, and then sold it back to you for whatever, $2,000. So that's what Apple did, essentially. So it's essentially a free software, Unix, and then you can take and modify it. So some of these are free. Linux is free, all of these are free. But Mac OS, for example, is not free, so you pay for it. Okay.
And they all use C programming.
It was written in C. So even operating system is a software. So to write a software, any software, you need a programming language. So the programming language that we learn in this course is R. But another programming language is C, which was one of the first programming languages. And programming languages help you write code and build software, which then helps perform a certain task. For example, the user can then load up a program using that you've written, and then that program can help the user do a certain task. Like it can submit jobs to the cluster. It can open up and tell you what the date is. It can tell you what the calendar is. It can tell you how much time it took for this job to execute. All of that stuff there are programs written in Unix that are actually written in C. Yeah? Does that make sense? Okay. So it's a very active community that still works on Unix. They still keep evolving it. There's more Unix versions coming out, more Linux versions coming out. If you have kids, there's a Linux version for kids that you can install on a simple Raspberry Pi and build literally a Raspberry Pi is $40. Right? So if you have a used monitor at home, a used keyboard and a mouse, you can buy this $40 thing. It's literally this big in a box. Some of it actually comes with Linux installed in it, and it works as a regular computer. Like you can give it to your child and they just use it, and it's free. Like the Linux part is free. The only cost you have is this $40 machine, which is again nothing. So that's the cheapest laptop, cheapest computer desktop you can build, and it's built with Linux. And there are kit versions that you can install on your own computers as well from Linux, which have all these, you have free Minecraft on it and free all these other things if you're interested. Okay. All right, more stuff. So your account, each user has their own space called your account. So when you created your account on ERS1, the server, if you have, if not, you will do it. This is your own space, meaning nobody else has access to it. Meaning this is your, area of, it's your domain. You type in your login and password to get into that account. So when you created your account, you would have gotten a login ID. Your MGH ID is your login ID. You understand? So there's like mine is VT094. I can tell you my login ID, makes no difference. You can share it, it's no problem. The password is the one that will, obviously, it'll help you get into your account, and that's what's yours. You don't want to tell that to anyone. And it'll only log in if the login ID and password match. All right? So that's very standard. So let's say, you have your ad, you enter your ad is your login ID, enter password. So when you type password and return, the password doesn't type out. There's no asterisk or nothing prints out. Right? So as you're typing your password, it's actually being typed. Even though on the screen, nothing is happening. Does that make sense? You'll see this in practical. Because a lot of times people will be like, oh, I'm typing the password, I don't see anything happening. Because you're used to seeing the stars appearing, the asterisks appear, nothing happens in Linux. You just type your password, it does not appear, you press enter, and there's something similar to this dollar, it's called a prompt. This dollar sign will appear on your terminal. And we'll open a terminal, we'll tell you what a terminal is, and once this appears, then you are logged into the server. So your computer becomes a client. On that client, we open a software called a client window or a shell window. And that shell window helps you log in by connecting to the server. And by the end of the class today, practical today, we will have done this. We would have logged into the server, and we would have done a lot more stuff than just logging into the server. All right? That's the fun stuff. Okay. Once you're logged in, that means you've established a connection to the server. There is now a bridge. In your computer, there is a window that has opened up. It's usually a white colored or a black colored window, which now has been connected to the server. So now you are actually, that window is a portal into the server. Anything you do in that window is actually happening on the server. It's not happening on your computer, it's happening on the server. Right? Where is it happening? It's on your directory in the server. That's where stuff is happening. Right? So once you're done whatever you want to do in that window, you have to say log out, and you log out and you're done. Right? Correct? Most of you have seen this window. It was in Mission Impossible and all those movies, when the hackers are logging in, they're trying to hack into this account, and they're, oh, I have to log into the server. And that's the black window that appears that computer programmers are always typing furiously, really fast. I don't know how they type so fast, but they're always typing, and that's what's happening. They have to, denuclearize the missile codes and stuff. Okay. All right. So if you are stuck in that window, there is a command called man, standing for manual, meaning help. It's not gender specific, it just means man for manual, manual pages. So you can say man with a command name, and it'll tell you what that command does. So this is the first thing you want to learn, just because sometimes you don't know what the command is or what the options are. So this is an easy way to get a help on whatever your command is that you're stuck with. Sometimes you don't even know what command you want to find. So you can say topic, which is, let's say, an apropos. So apropos topic lists the commands that are related to a topic. So let's say you want to see directory. How do you make a directory? How do you remove a directory? So you say apropos directory, and it will list you all of the commands that are relevant to directories. Does that make sense? Okay. So man helps you find specific commands. So if you know, the command to list a directory is ls. Right? Let's take that as an example. So the ls command gives you the contents of a directory. So in Finder, you open your Finder. Okay. One big thing, which is, I think that's the part where your mind is not able to imagine. In Unix, there are no graphics. There is no pretty windows. There is no mouse. You can't click and open anything. So everything has to be typed. So in Finder, you can click Finder. You go to the menu. It says New Folder, and a directory or a folder is created for you. Correct? To do that process in Unix, let's say you are in that shell window, the hacking window. You have to type in mkdir folder name. Mkdir is a short for make directory. Okay, so the same thing that you have to go click and open new window, make new folder. You have to type, and then let's say you don't know the mkdir command. Let's say you are confused, like, well, how do I make a directory? So you can say apropos, which is the command directory, which will tell you that here are some specific commands about how to do stuff with directories. So it'll tell you, oh, ls command, mkdir command, other commands. All of those commands are commands for directories. At which point you can say man mkdir, man ls, and then it'll tell you what each is. Right? Again, this will make a lot more sense once we start actually typing these commands in the terminal. All right. So for now, bear with it. That don't go back to the goal, the big picture. There are commands that help you do stuff in Linux. That's the purpose of this slide. Not to learn what the command is right now. Okay. You will have more than enough time later on to find about that. Okay. So this is just a customary slide. Frankly, there are enough books on the internet. You can just click, and I've uploaded a book as well on the course website. So if you want, you can just go there, and there are enough of that. But if you want more and want to go in depth, there are some books that you can look at. All right. So here is a systematic diagram that I find most of you will find confusing. But I'll go over it anyways. The purpose of this diagram is to explain the relationship and how Unix works as a system. All right. So as a system, you as a user are here on the outside. This is your, you're sitting here, and then you open a shell window, which is this black terminal window. All right. That terminal window has applications and software inside it that you need to know what these are, and you need to have permissions to access those applications and software. If you do have those, you will type a command that will access that software, which will then go and ask this layer, intermediary layer called the kernel, permission to execute and work on the hardware, which is your hard drive and other things. So that's basically how your command goes in, and then the response comes back the other way. So the hardware, it has done stuff, it will tell the kernel, here's a successful outcome. Or I could not do this because this was illegal. And so the kernel tells the software, look, this person messed up, or this is the output, it's success, and the shell shows you that result. Right? Does that make sense? Is it clear?
Is the kernel sort of an interpreter?
Yes, the kernel is, all of this is software. Software, 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 and this is hardware. So these three layers are layers of software. But it's like an interpreter, or it's basically a software that's entire purpose is to create a barrier between the hardware and the other existing software that will access the hardware. So in order to go to the hardware, you have to go through this kernel layer. And this layer is very protective, and it only works with certain permissions. So every user has a specific permission set. So let's say a super user can call a software or issue a command, and that command will go through the kernel, and let's say the super user tries to delete everything on the hard drive. That it will allow because the super user has the permissions. But you and I, as a normal user, if we issue a Unix command to delete everything from this hard drive, the kernel will immediately block that request. And the kernel also helps one user's commands keeps separate from the other user's command. One user's space is separate from that. All of that is handled by the kernel. That's like the main person in charge, the main software in charge, right? And then all your software, your commands, your tools, everything lives in this layer, which is separated, which is accessible to you from the shell. But that layer, again, that software doesn't have direct access to the hardware. It has to still go through the kernel. Does that make sense? And this actually makes the Unix operating system very secure. And that's why there are less viruses. There are still viruses in Linux, but there are much less. There are much fewer. Because let's say you download a software on your own, you manage to get here, and you start running this software, right? And it's a malicious software that has a virus in it that intends to wipe out this hard drive. The kernel will first, because you have launched and you don't have the permissions, it will stop this right away from erasing this hard drive. All right? Although nowadays people have figured out ways around it. Okay. So here's another example or another diagram that explains what it is. So in your shell, which is that black window that will listen, there's usually a prompt that is on display, and it is always ready to look at that. It's always ready to receive your command. Whatever you want it to do, it's ready to receive that command in the shell. So there's a display prompt, that $sign. It reads the command that you enter. It then processes that command and executes that command and gives you the results on the display prompt. So it's a cycle that happens in the shell, right?
So this is actually represent the kernel shell relationship,
Exactly.
but like in
a
a simplified way.
In a simplified way.
Perfect.
Same thing, but in a simplified way.
Exactly.
Cool? Okay, I'll take a breather. Questions so far? Any questions? No? Okay. Alright, so these are some of the commands. Even though I said try these, we'll try them in the practical portion, which shouldn't be too much. But let's say, for example, you want to find out what is the calendar for March 2016. All you have to do is type out this command in your terminal, in that shell window, and it actually displays you for the month of March, what is the thing. Alright? And these are some other commands which, again, we'll tell you as we go through it.
Excuse me.
Yes?
Now, are these commands the same for every
Unix system, they are.
Unix system?
Yes.
But for the modified one, for example,
For
the
Linux also they'll work.
they
They will all work. So once you have learned one Unix system, all of these commands will work in all Unix systems. There might be additional commands that are available in some of the systems,
the updated
but the
one.
basics ones will always be the same. Right? Here's an important command. Partners makes you do this online, so you have to go online and change your password, but you can also do it using the password command. So you type PASSWD. You know how you have to change your password every 3 months? Right? Technically, for a Unix system, you can just go say password, type in your new password and the old password and enter it, and it'll ask you new password twice, you enter it, it changes your password. Just don't enter the wrong password twice. Okay, so here are some commands for date. Like I said, this one, calendar, date, these are all very simple. For whatever year, going back, 20, 30,000 years, you can just type that number with the date, and it'll give you the calendar of that year and the date, right? These are some commands that help you between you and the system. For example, you want to see how long has the machine been up, meaning how long has the machine been working, what is the host name of your machine. So this is important because sometimes you want to connect to your machine, you don't even know what the name of the machine is. So every machine or every server, when I say machine, I basically mean server. So every machine or server has a unique name, just like all of us. I mean, most likely combined with our first name and last name, it makes it unique enough. Sometimes that doesn't happen, so we have middle names. Either ways, when we have a name, it's unique to us. When I say that out loud, usually, normally only one person will respond. And that's what, on the internet though, they ensure that by having a unique host name for all servers on the internet. Every server on the internet has a unique host name. Does that make sense? So our host name for our computer is, on the server, is erswan.partners.org. Alright? That's our unique host name. So if you want to connect to that computer, you will connect with this host name. Does that make sense? Okay. And then on that server, if you can go and type in who am I or who, and it tells you who all are on the computer. Who am I tells you your name on the computer. So my name inside the server's realm is not Vishal Thapar.
It's the username.
It's my username. Yes.
I have another question.
Sure.
So you said that the Unix is written in the C language,
Yes.
and what we will learn in this course is the R language,
Correct.
which is another software, or correct?
Yes, correct.
So
R is also
the
written in
commands
C.
are still similar because these commands are specific for Unix.
The concepts are similar, the commands are not. So R is a high-level language. It's a lot simpler than C.
Oh,
C language, we are not learning C. C is not something that we learn just because it's a lot of hard work and, in fact, C was so hard that they had to write, C++ and Java to make it simpler. Like C has all these things about pointers and garbage collection, which was a huge issue in C, memory allocation. I don't want to get into that, but let's just say C was a tough language. So they wrote simpler languages, like C++, like Java. And then even simpler than that is R language, which is why we learn R, because that is a lot simpler and it is very powerful for biologists and statisticians to work with. Okay. All right. So just an example. There are dates. You have calculators. All the stuff basically that you have in your Mac as GUI stuff, like with Windows. You type calculator in your Finder and a calculator opens up. You can do the same exact thing in Unix, except you have to type everything out. Right? You just can't click.
yeah.
So you have to type it out. So that's what I'm trying to show here. Alright, so here are some other commands. Again, this is just a snapshot of commands. We'll do some of these in our practical, but the point here is not to just say that these are important. The point here is to show these are some of the commands that people use. That said, apart from this, there are thousands of other commands that are also there in Linux or Unix, which we're not going to be able to cover in this course, but we will cover the important ones that we use on a day-to-day basis. Everything that we use in a day-to-day basis, and by the end of the month, next month, or this month, or midway through next, you'll be able to see. Okay. All right. Okay. So here is a symbol that is like this. What symbol is this?
Greater.
Greater than sign. So this greater than sign is actually a very useful symbol in Unix. It can be used to redirect the output of whatever is to the left of this to whatever is to the right of this sign. So think of it as a gateway. I look at it as like this output, for example, let's say there is a directory and I want to know the contents of the directory. But not only do I want to know the contents, I also want to store those contents in another text file, and then I want to print that file. All right? So what I can do is I can say ls, which is a command to get me the listing for whatever is in that directory. So ls commands in that shell window will give me everything that exists, all the folders, files, subfolders in that directory, and I will redirect it to dir.txt, which then becomes a text file. So this new file is created, which has the contents of this file. So I didn't have to open Word, I didn't have to open Notepad to copy, paste, and make this. All I did was I said ls redirect dir.txt, and lo and behold, a file is ready for me. Now I can click on. Now I can download that file, double-click it, and print it if I want to. Same thing here for calendar. You can print out the calendar for an entire year just by using this sign. All right.
You mean read it? as in?
Well, you'll have to download it, and we'll cover how to download and how to upload, download stuff. But you won't be able to print it from the server because it's, you know, a different computer. That said, in your own house, let's say you have a computer that has Linux installed on it, and you're working in Linux, you can type print dir.txt to and redirect with the name of the printer, and it'll actually print it on your printer as well. But that can be done, but it won't be possible in the server because the server is a separate machine that you're logged into, and it doesn't have any printers connected to it. Okay. So this is the way to create a new file. But let's say you want to add to an existing file, then you can use these double greater than sign, and it will add to an existing file. All right. So let's, for a second, pause here and see, is this relevant to our data analysis? And can we use it to our data analysis? So here's how we can use it. Let's say you sequence in your data, you just get back your data is in 4 text files, right? And you want to combine all of those 4 files into one file. All you have to do is whatever the command to read a file, you say read file 1 to file and create a new file. Then you say read file 2, double greater than, to file the new file. Right? So this way you can add all 4 FASTQ files or all 4 sequencing files into one file. Okay? So I'm just saying, keep your mind back to how you can use this for your projects. Pipes. So this is another useful feature. This, just like this sends the output to another file, greater than sign, a pipe sends the output to another command. So let's say there are 2 commands. One command is ls, which is the listing, and another command is sort. So sort command sorts your data alphabetically. All right. So say you want to sort the listing for a directory and then save it to a file. So you want the contents of a directory, but you don't want just the contents, you want them in alphabetical order. So you say ls, and then you use this symbol called pipe, and say sort, and then you can say redirect to dir.txt. Now you have a sorted directory file. Does that make sense? Okay. So I'm not going to go into this, but basically, you know, these are the important stuff, and the rest is fine. You don't need those. Okay. Right. So how are we doing on time? We still have 8 more minutes. The file system. Okay. So everything in Unix operating system is a file. Now this statement will confuse you a little bit, because we, in our minds, we are used to seeing and associating things differently. For example, when you open your Mac or Windows, you open this and be like, oh, this is a folder. A folder is different from a file, right? In your head, a file is a Word file. A file is a text file. But in Unix, even a directory is considered a file. So a directory is considered a file that contains other files. Does that make sense? So everything in Unix is a file. So there are ordinary files, which are like your text file or program files or whatever files you have, correct? And then there are your directory files. The directory files are essentially folders, but they are called files. Does that make sense? And for all practical purposes, any command that works on a file most likely also works on a directory. For example, you can copy a file to another location. You can copy a directory to another location using the same command.
Which is a folder.
Which is actually a folder,
Okay.
but that's the way to write it stays the same. It stays the same, meaning you can write the same command as in cp. So you can say cp directory name and new directory location.
So the ordinary file and the directory files are different because the ordinary represent a normal file and
Exactly.
the directory a folder. But
But
the way
it is
you
still-
type their comments on the Unix is exactly the same.
Right. Some of them, some commands will work only on directories. Either way, the point is, they are represented internally. The internal representation is still considered a file. Does that make sense? Okay. And device files. So this is the third kind of files which you will probably never use, but essentially it also treats, let's say you have a DVD drive attached to your server, it considers that also as a file. Okay? Because it is a device, but it is still considered a file. So you can copy a device and move it, or if you have the permissions, you can delete a device. So let's say you install, you connect a DVD. So that's basically, it looks at it and thinks of it as another file that has just been added. So, and then you can remove it or delete it, and all of those things that you can do with files can be done with devices as well. And so a hard drive, for example, is a device. So if you connect an external hard drive, it still thinks of it as a file. Does that make sense?
Is the USB considered as a device
Yes.
file?
So USB, if you connect, that's another device, but it'll be a device file. Good example. Okay, so now that we understand what directories are actually files, but in Unix, everything is very structured, kind of like a hierarchy at a company, right? So at the very top, you have the root, or the CEO, or the CEO, or the president of the company. So this root is where the entire file system in Unix begins. All right. This is represented by this /, just the /. It's a very simple way, and that's it. That's all it is. That represents the name of the root or the primary first location in the server. Okay. The next thing within the root are these other directories: etc, bin, user, dev, temp. In our case, there's a directory called phs home. All right. So you can create directories as if you have the privilege or given the user privilege that you. So supposing I'm a system administrator or I'm a super user, I can go in the root directory and create a new directory there. You don't have permissions, neither do I. But if you did, you could go into the root directory and say, make directory phs home, and that's what they did. They created a phs home directory. So instead of user one, we have phs home, and then these are some other directories. Each of these directories then can have subdirectories. You will be located in the second level here. So this is where you are located, or your user account is located, and 2 levels below the root account. So there's root, there's phs home, and then there's user, your user ID. Okay? Does that make sense?
rs1 is a directory.
rs1 is the name of this server. Within
Okay.
that server,
Okay.
we have this as the structure of files that are stored in this server. They will be stored in this directory tree. It's a tree, and somewhere on this tree, your data, other data, your other lab members' data, all of it is going to be stored in this, somewhere on this tree. It's like a leaf that you will have. So the programs, for example, let's say are you familiar with, what programs are you familiar with in Unix? Have you used any program, for example? Are you familiar with Top Hat, the aligner, star aligner? Anybody heard? Let's say there is this aligner that aligns your data, right? Let's say its name is star, right? That star aligner will be stored somewhere, say, on bin directory. Or it will be stored somewhere in this directory. You create a new directory called software. Under software or apps, you have the apps directory in Mac, right? You have the applications folder. That is right here under root applications. Your Mac follows the same structure, by the way. Mac file structure is exactly the same. You have root, you have applications directory, you have trash here, you have some other bin directory. All of these directories are there in web. Even in Mac, you have your root, your name of your MacBook, and then you have your name. So users is here. In Mac, you have root, users, and then in my case, it's my last name, Topper. Or you can look at it in your Finder. You will be able to see that there are 3 levels between. There's 2 levels between your name and the root name in your Mac. Okay. It'll become more clear as soon as we start the practical. So let's get to it fast. All right. So these are some of the FAQs. I won't go over this today, but we'll go over this next time, along with other questions that you send me. All right. So we'll go over these questions. They'll become clear next time. All right. So as I said, this is the root directory. This bin directory creates all the commands. So the commands that we talked about, ls, mkdir, all of those commands are stored in this bin directory within the root directory. Okay. And then the etc directory contains all the password file, data files that are for the system, right? And then the dev directory contains the devices or your I/O device files. Okay. All right. So here, I think. Slides. I'm gonna stop here, just in the interest of time, and let's do some practical. All right. And tomorrow we'll come back and we will cover either. We'll cover from here, which is the directory structure. So it'll take 15 minutes tomorrow. Is everybody attending the lecture tomorrow?
I will be late. I have to fast before
You have to? Facts. Okay. Alright, so some of you will not be here. Like 2, 1.
I don't think I'll be here. I think
Okay.
I don't know next time.
Alright. Well, we can go over it in the next class then. Alright?
Are these files online? Otherwise, I can just
Yeah.
like click on them online.
So these slides are online. So you can basically go and start reading from here. And you know, we basically talk about, you know what, I'm going to go ahead and go through it anyways. Just because if people are not coming tomorrow, then I'm going to spend another 10 minutes and then we'll do the practical. Does that sound okay? I know you guys want a break.
So we're not meeting tomorrow.
No, we will meet tomorrow, but because the people, some of them are not coming tomorrow, so I figured I'll go through it now. Yeah? Just 10 more minutes of your attention, alright? Okay. Yeah, no problem. It's on video, so you should be able to watch this.
Yes.
Okay, so now that we understand that there is a directory structure, there's a root, and then we have that tree, then we come to the next thing called as a path name. A path name is very important because it essentially identifies where in the tree your file or directory lives in, right? So the location from root to that directory or file is called the path name. Okay, does that make sense? For example, the path to the bin directory is /bin. The path to the terminfo file is /etc terminfo. The path to an add file or directory is /export /user /home /add. Does that make sense? So basically, from the root, how many, which branch do you go to till you end up where your file of interest or directory of interest is? That's called a path. Okay. Now there are two kinds of path. There's absolute paths, and then there is relative paths. Absolute path is the exact sequence of directories you take from the root, and it's always from the root, the absolute path, because it tells you the full name from the root to the directory. The relative path, unlike the absolute path, can be from another location to a new location. For example, let's say you are interested in the directory project 1 and you are in this directory S390. So you are in this directory and you are interested in this directory project 1. Now, if you are in this directory, then project 1 is directly in your directory, correct? But if you are in the home directory, then it might be that that home directory is below this, so or above this in the tree. So project 1 is now relative to you, it's just this directory / this directory. You don't have to go all the way from root. You can actually access it just by saying, this directory, this directory.
But you cannot skip any path. Like you have to follow.
In the absolute path, if it is, say, in your reach, so if it is as part of your branch, if a directory or file is in your branch, you can mention the name of that from where you are. But if you don't know where the directory is and it is not in your directory, then you can mention the absolute path. So let me go back and explain. I think there's a diagram later. Here. Okay. So this is the directory, right? Say we are in this directory. Okay. And this directory, let's say that there is a directory called home on top of this, and that home is, on top of home is root. So there's root, home, and then this directory. Alright? Now, within this directory, there is this file, there is a project directory which has a bunch of other files and directories, and then there's a project 2 directory which has a bunch of files and directories. Alright? Now, supposing I want to access, I am in this directory, and I want to access this project 1 directory. I can simply say, whatever, I can simply go directly to project 1 directory, correct? Because I'm right here. All I have to say is, oh, ls project 1, and it'll show me the contents of project 1 directory, right? Now let's say I have changed my directory using the cd command. I can change a directory, and now I'm in this project 1 directory, okay? Let's say I want to access a file in project 2 directory, correct? So one way for me, because I'm in project 1 directory, is I can just say, let's say the command I want to do is ls. I say ls/home/s3910/project2/file name. And then it will give me the listing for that file, correct? That's the absolute path. Or I can use what is called as a shortcut way or a relative path by using these two things called as these dot operators, which is essentially this dot dot. To move one level backward, it's called dot dot. Okay, so I can say I can say ls dot dot, which brings me. So I was here. I say ls dot dot, which brings me here. Then say /project2, and now I have the directory for project 2.
So no need to go
All the way.
up.
I can use a shortcut,
This is relative.
which is relative, because it's relative to where I am. Okay?
And since you can use relative, which is
Sometimes relatives can
Easier.
get very confusing.
exactly, so why
So-
we have
so
to
it's-
use the
So sometimes relatives is confusing, so that's why I use absolute. Because let's say I'm running a program and I don't remember where I am, but I know that I know the absolute path, but I don't know which directory I'm in. So it's easier to, rather than saying dot dot slash project 2, say I'm here. I say I have to go dot dot slash project 2. Or I can just say /home/this/project 2. Whichever is easier, they both mean the same thing. Alright. Okay, so we've done this. So here's the example that I just told you. If I'm in project 1 and I want to move to project 2, I can just say cd dot dot /project 2. So cd means change directory. So if you're in one directory, you can say cd and it'll get you there. So this is a relative path. Does that make sense? Okay. Alright, so apart from that, there are some special directory names like this. This refers to the root directory, as I was talking about. This is the name of the root directory. Everybody knows this. / means root. Dot means the current directory. So dot dot, 2 dots means the parent directory, meaning the parent of in the directory tree. What directory comes above you is your parent. What directory comes below you is your child. So dot dot is your child, is your parent directory. Dot refers to your current directory. So you can also say dot slash instead of saying just, say you are in home directory and you want to go to project directory, which is right below you. You can say cd /home/project, or you can say cd /project because you're already in home. Dot refers to whatever directory you're in. Okay? And lastly, if you type this tilde sign, it brings you from wherever you are on the server. Let's say you are in directory data, ting, home, blah, blah, blah directory, and you just want to get back to your home directory. You can either type cd and press enter, it brings you to your home directory, or you can type cd tilde, which also brings you to your home directory. It's a shortcut. Okay, right. So we will use this in this, and all of this mkdir, all of this we will do in our thing. Permissions we'll talk about later. Let's try out some practicals. Let's give it 2 minutes or 3-minute break, and then let's get back here and we can work on the practical together. Okay?